Hey guys, this is Mrs. Tran-Bloom. We're going to continue or start 6.3, okay? So section 6.3, properties of the trigonometric functions. So let's review a little bit. So it says here, let P be the point x comma y on the unit circle. So here's a unit circle. That means the radius is, so here is the radius of 1 unit because it says P is on the unit circle. And here's a point, it's on the circle itself, and it says, hey, it's some unknown x and some unknown y. And of course, I'm going to make a right triangle by drawing the right angle on the x-axis. So this is what we call the standard form, right? If this point is x comma y, then this distance has to be x, and this distance has to be y. My radius, let's call it r. R is 1 unit because it says the point is on the unit circle. So let's review. Sine of, let's call this angle theta. So sine of theta equals to adjacent over hypotenuse, which is r. Okay, but because it's on the unit circle, we can say that it's x over 1, which is x. Keep in mind that it's not always going to be on the unit circle. So, but if it's on the unit circle, it's gonna be just simply the x coordinate. Oh shoot, I just did it wrong. I'm sorry, sine is y over r. My bad, sine is opposite over radius. So this is y over 1, and so this comes out to be y. Cosine of the central angle is called theta equals adjacent, adjacent over radius. And because this is the unit circle, my radius is 1. So cosine is simply x. So this is kind of like cosine comma sine. Tangent of theta equals opposite, which is y all over, adjacent, which is x. And in this case, we can't really reduce. Cosecant is the reciprocal of tangent. So cosecant is going to be 1 over tangent of theta. And 1 over tangent, if you look at this, right? Well, if this is y, which is similar to sine, and this is cosine, so I can also go, I can do the reciprocal, which is x over y, which if it's on the unit circle, we can also say cosine of theta all over sine of theta, right? Because x is going to represent cosine, and y is going to represent sine. So we can we have multiple ratio here that it's going to mean exactly the same thing. Then we also have secant. Secant is the reciprocal of 1 over cosine of theta. Okay. So cosine is x, so we can say 1 over x. Cotangent, I just did, oh my goodness, I'm totally spacing out here. I just did cosecant completely wrong. I'm thinking cosecant is cotangent. My bad. Okay. Hopefully you can erase this and do it again with me. Cosecant is the reciprocal of 1 over sine. I'm so sorry. Okay. And sine is y, so this is just simply 1 over y. Now cotangent, this is what I really want to get to. Cotangent is the reciprocal of tangent. So it can be 1 over tangent. Okay. And 1 over tangent, because tangent is y over x, 1 over tangent is x divided by y. Or we can also take the ratio of x is cosine and y is sine. So we can also have the ratio of cosine over sine as well for cotangent. So these are just the reviews. Now, what I want to get further into this is some identities that some of you may have already known. Okay. So let's talk about this particular right triangle here. Would you agree that by using Pythagoras, and this is really important, okay? So we now know that y is sine of theta and x is going to be cosine of theta, okay? So based on a unit circle here. If I needed to use Pythagorean theorem, I would just say that a squared plus b squared equals c squared by Pythagoras. Well, I don't have a and b and c here. I simply have x and y. So using our triangle, we have x squared plus y squared equals radius squared, okay, a, b, c. Well, radius is 1, so now I can just write x squared plus y squared equals 1, because 1 squared is just simply 1. Well, here's the first really important identity if you have not seen it before. X squared, well, x is going to represent my cosine. So this is similar as cosine square of an unknown angle. Plus y represents sine. So that's going to be sine square of an unknown angle equals 1. And this is always true. So if your angle is 30 degrees, then cosine square of 30 degrees plus sine square of 30 degrees equals 1. Or it can be 15, it can be 1, it can be 2 degrees, whatever it is, or radians, okay? Now, a lot of you think that, hey, this is cosine square. Cosine square doesn't really mean anything, right? So let's bring this up for a second. If you guys write sine square, it really means nothing. It's like saying that sin square, okay? And sin, if you square sin, it really doesn't mean much. Or mathematically, if you go, hey, division symbol square, what on earth is that? It looks like a smiley face to me sideways. So sine and cosine, any trig functions that you are using, you need to have the angle. It's sort of like the operation, okay? Cosine and sine and tangent, you're about to do something with the angle. It's the operation of it. So you can't just really write sine and then nothing behind it. So with this identity, this is what we call the Pythagoras identity, okay? So Pythagoras identity. And it's so important. This is one of the identities that you're going to have to know and memorize and use it over and over again, okay? Now from this identity, I can always manipulate, right? I'm going to take cosine square of theta plus sine square of theta equals 1. What if I go and divide each and every term by cosine square of theta? Why not? I can divide as long as I divide each and every term by cosine square of theta. Cosine square of theta divided by cosine square of theta, I'm going to end up with 1 plus sine square of theta divided by cosine square of theta. Well, sine square, sine is y, cosine is x, y divided by x is going to be tangent. So this becomes a tangent square of theta equals 1 over cosine square. Well, if I look at this table right here, 1 over cosine is secant. So this becomes a secant square. So this is going to be a secant square of theta. And this is another identity that you don't have to memorize. You can just come up with it or derive it yourself if you don't need to memorize it. But if you memorize it, then it's just going to help you, or you know, you get the answer quicker. But again, you don't need to memorize it. You just need to understand how we came up with it. What if I take the same Pythagoras identity, such as the original, cosine square of theta plus sine square of theta equals 1. And instead of dividing each and every term by cosine square, I'm going to divide each and every term by sine square. Okay, so sine square divided by sine square. And if you've never seen this before, this is how we come up with multiple identities. Well, cosine squared divided by sine square of theta. So cosine over sine. Let's look at which one we're going to use. If you check this out, this is cosine over sine. So technically, that will give me cotangent. But because this is square, so it's going to be cotangent square of theta plus sine squared divided by sine square is simply 1 equals 1 over sine squared. Well, sine is y. So which one has 1 over sine? It's cosecant. And because this 1 over sine square, it becomes cosecant square of theta. Okay. And this is another identity that we came up with by just dividing everything by sine square. This is another identity that we came up with by dividing everything by cosine square. So do you have to memorize these? No. But am I going to give it to you during a test? No. If you're not going to memorize these, then you need to understand how you can come up with it. But you definitely need to know this, okay? With that said, let's go and do an example. Okay, so this is the next page in your notes. It says review, find the exact value of each trig function. Most likely I'm going to do this as a warm-up if we have not already done so. So we're not going to do this in a lecture video, but we're going to do with example 1. Okay, let me zoom in. Example 1, name the quadrant in which the angle lies. So angle theta lies. it says here, hey, sine of theta is greater than 0. That means whatever angle this is, when I find the value of it, it has to be positive. So let's talk about this right here. Sine of theta is similar to y in a unit circle. So y is positive in quadrant 1 or in quadrant number 2. So my answer is going to be quadrant 1 or quad 2. Okay. I'm going to do 2 more and I'll leave 1 for you. Tangent of theta, it's asking you to do also tangent is positive. So tangent of theta is similar to saying that, hey, sine of theta divided by cosine of theta. And sine is similar to y and cosine is x. So whatever it is that I'm dividing, I need to get a positive answer. The only time that you're going to get positive answer is both y and x. They both have to be positive, which is quad 1. Or both x and y got to be negative, so quad 3. So the answer to this one is quad 1 or 3. Okay. Alright, I'm going to leave C for you to try on your own after I do D. So here we go. We're going to skip to D for now. So cosecant of theta has to be negative. Well, that's interesting. Let's talk about what cosecant of theta is. Cosecant of theta has got to be the reciprocal of sine of theta. And sine is similarly to 1 over y. So when it's y, negative. Because 1 is always going to be positive, and that's not going to change. So we're looking for when y is negative. Because 1 divided by a negative number is a negative. So y is negative in quadrant number 2 and number 3 and number 4. So my answer for this one is quad 1, 2, 3 and quad 4. Okay, so that's going to be my answer. Now I'm going to ask you to find the answer to part C. So this is going to be on your own. Okay, and if you need to, just write it out. Okay, secant is the ratio of what? What is it the reciprocal of? And then go from there. Go from your basic knowledge. And if I'm going too fast, please just hit pause and work out C. Because if you are going to wait, you're going to forget about it. And when I check your notes next time, you're not going to get credit because you have forgotten to do it. Okay, now we're on part example 2. Example 2, find the exact value of the remaining trig functions. So remember there's 6 of them. There's 6 trig functions. I gave you sine of theta already. So sine of theta is 2 over 5. And I'm also giving you another piece of information here. Cosine of theta is negative. So I'm going to draw a particular coordinate plane here. Sine is positive 2 over 5. So I can only have it in quad 1 or quad number 3. And it says that cosine of this same angle is negative. When quad 1, everything's positive. In quad 2, cosine's negative. So this is where I'm going to draw my angle. Oh, I'm sorry, my triangle. Here is angle theta, whatever it is. I don't know what it is. I don't care what it is. So sine of theta equals opposite over hypotenuse. So currently I know 2 measurements out of the 3 of this particular triangle. I can definitely find out what this is. So using a squared plus b squared equals c squared. A is 2 squared plus b, something I don't know, which is this piece right here, equals 5 squared, which is my hypotenuse. This is 4 plus b squared equals 25. Subtract 4 to both sides. B squared equals 21. You are going to take a square root. Okay, so b equals square root of 21. So this is where I'm going to put square root of 21. Now technically, this is a measurement of a distance or a length. So there's no negative or positive. But because I am in quadrant number 2, I'm going to say that, hey, this is a negative, not 21. So when I write my answer, I don't forget that it's negative or positive. So it says find the exact value of the remaining trig functions. That means I'm going to have 5 more to find because sine is already given. So here you go. Cosine of theta. And no, you're not looking for what theta is. You're looking for the ratio of each trig function. So tangent of theta, cotangent of theta, cosecant of theta and secant of theta. Okay. All right, so here's the same triangle. You're not going to draw anything new. Cosine of theta is going to be adjacent over hypotenuse, so negative. See, notice how because I wrote negative here, I know to put the negative back on my answer. Tangent of theta is going to be opposite over adjacent, so negative 2 over rad 21. You're going to rationalize this by multiplying top and bottom by rad 21. So my final answer is be negative 2 times rad 21 all over 21. I'm going to box that up because I have some work here, so I want to make sure this is clear for my teacher to know that, hey, this is actually the final answer. Cotangent, I'm just going to take the reciprocal of tangent, so negative rad 21 over 2. And I don't need to do any work because it's already rationalized. Cotangent is the reciprocal of tangent. So cosecant is going to be the reciprocal of sine. And sine is 2/5, so cosecant is going to be 5 over 2. Secant is going to be the reciprocal of cosine. So what I need to do is I'm going to flip this. So negative 5 over square root of 21. I need to do a little bit of algebraic. Take the square root of, multiply both top and bottom square root of 21. This is going to be negative 5 times rad 21 all over a positive rad 21. So I believe I have box 1, 2, 3, 4, 5 solutions, and I'm looking for the remaining 5 trig functions. And that's beautiful, right? Okay, so what I'm going to do is I'm going to do another one, and I'm going to leave these two in the bottom for you guys to do. So let's check this out. Okay, so it says here, sine is positive, so let's draw it out. Sine is positive in this quad and this quad, okay? Cosine, it didn't say cosine is less than 0. It's just telling me that cosine is a negative 2 root 505, which is telling me, hey, cosine's negative. So it looks like I'm drawing this right triangle in the same quad 2 as the previous example. Well, you can attack this in a couple of different ways, okay? And I'm probably gonna show you both ways. Would you agree that sine is going to be opposite over hypotenuse, and cosine is going to be adjacent over hypotenuse? Okay, if you believe that's true, then let's talk about what your hypotenuse need to be. If you look at this, would you agree that this is the answer once you are done with rationalization? So if it's before rationalization, would you agree that it's going to be 1 over square root of 5? And over here, would you agree that the answer before you simplify is going to be 2 over square root of 5, and there's a negative in the front? So these two right here is going to be your pre-simplify solutions, right? So if I know that and I want to check, hey, square root of 5 is between 4 and 9, right? Between square root of 4 and between square root of 9. So I know that it's about 2.2 if I have to guess what square root of 5 is. And as long as my hypotenuse is the largest, then I know that's probably going to be correct. So right now, okay, I know right away my hypotenuse is rad 5. Sine is going to be opposite, which is 1 over rad 5. And cosine is going to be adjacent over square root of 5. Okay, so this is a method that if you see it, this is what you can do. And then I'll do another method that, hey, what if I don't see that? Then what can I do? So I'm missing a couple of trig functions, okay? Currently you have 2 right here. All I have to do is find 4 more. Cotangent of theta, oh, this is theta here. Tangent of theta, cosecant of theta, and secant of theta. Okay. Cotangent of theta is going to be, tangent is going to be opposite over adjacent. So let's do that first. Opposite over adjacent, which is 1 over negative 2, which is really negative 1 over 2. No one really writes a negative 1 in the bottom. There's nothing wrong with it, it just doesn't look cute. Then cotangent, all I have to do is flip it. So if I flip negative 1 over 2, I get negative 2 over 1, which is really negative 2. Cosecant, I just have to take the reciprocal of sine. So if sine is opposite over hypotenuse, then cosecant is hypotenuse over opposite, or simply write square root of 5. Secant, it's going to be the reciprocal cosine, and cosine is adjacent over hypotenuse. So if I were to flip it, I'm going to have hypotenuse over adjacent, which is really negative rad 5 all over 2. Okay. So those are my 4. Now, so let's talk about how would you find the answer if you did not see the pre-simplified version of it. Then you would just have to, you can still write, okay, you can still write this is x, this is y, this is x, and then find your y. Find your hypotenuse. So this is sine, which is similarly to your y. This is cosine, so similar to your x. Then from here, I just have to find the hypotenuse using Pythagorean theorem. So here we go. X squared, a squared plus b squared equals c squared. So this is square root of 5 over 5 square. You just have a little bit more work. Rad 2 rad 5 over 5 square equals c squared. Rad 5 square is 5. So 5 squared is 25 plus negative 2 squared is 4 times rad 5 squared is 5 all over 25 equals c squared. 4 times 5 is 20. 20 plus 5 is going to give me 25 over 25, which gives me 1. Okay, and square root of 1 is going to be 1. So your c came out to be 1. Okay. Alright, so if c is 1, this tells me that this is a unit circle. Okay, if this is a unit circle, then let's see what happens when I do cotangent, tangent, cosecant, and secant. So, tangent, opposite over adjacent. Okay, so let me, you know what? Let me create some space here because I don't want to be super. Okay, so tangent, here we go. Tangent of theta equals this problem, opposite, which is rad 5 over 5 over, which just really mean division, over negative 2 rad 5 all over 5. If I were to simplify this, I would have rad 5 over 5 times its reciprocal. Okay, so notice how this cancel, right? The rad 5 and rad 5 will cancel. I'm going to end up with a 1 on the top and a negative 2 on the bottom. Okay, if I have a negative 2, would you agree that this answer is identical to this answer? Oops, right there. So if you don't see it, you can still write out this is your y, this is your x, and find your hypotenuse regularly. You just have a lot more work to show. And still, but regardless, your answer is still going to be the same. And let's prove another one. I can probably do, let's do secant. Okay, I'm not going to find all 4 values again because the answers are going to be identical. But what if I want to find secant of theta? Well, secant of theta is going to be the reciprocal of cosine of theta. Well, I know what cosine is. Cosine is negative 2 rad 5 over 5. If I were to flip it, then it would be 5 over negative 2 rad 5. Okay, what if I rationalize that? Okay, here we go. Rationalization. That's fun. So on the top, I have 5 rad 5. On the bottom, I have negative 2 times 5. Would you agree that this 5 and that 5 would cancel? So I'm going to end up with rad 5 over negative 2, which is the same as this answer. Okay, so this is slightly longer because you have a little bit more algebraic to do, which I feel like a lot of you make silly mistakes during algebraic work. So if you can recognize that, hey, this is the reduced or the simplified version of this, then it's so much easier to know what the triangle is, or the measurements of the triangle. Okay? All right, do me a favor. For the rest of this today, can you please do these 2 on your own? Okay, both of them. And I would check it in class the next time I see you. Have a great day.